Hey, welcome. Today, we're going to pull back the curtain on something that makes all our favorite software work so reliably. We are literally going inside the code to talk about a super important quality check called white box testing. It's all about making sure software isn't just working on the surface, but that it's built right from the inside out. Think about it. We use apps all day, every day. You tap a button, something happens. It kind of feels like magic, right? But have you ever stopped to wonder how it really works? What's going on under the hood that makes sure it all runs smoothly? Well, that's the exact question we're going to tackle today.
To answer that question, we first need to get a handle on a huge concept in software quality: the difference between testing from the outside versus testing from the inside. You can think of it as the difference between being a driver of a car and being the mechanic who works on the engine. Okay, let's break this down with a really simple analogy. On one side, you've got black box testing. This is like having a remote control car and just pressing the buttons. Does it go forward? Does it turn left? You're only checking if it does the thing. But on the other side, you have white box testing. This is where you actually pop the hood, get your tools out, and look at the wires, the circuits, to understand how it all works.
So since we've decided we want to be the mechanic, not just the driver, let's officially crack open that white box and see what's really going on in there. And here it is, the official definition. White box testing is a method where testers, usually developers themselves, get full access to the source code. They're not just clicking buttons on the screen. No, they are digging into the internal structure, the logic, the absolute foundation of the app to make sure it's built solidly. Now, you might hear a few other names for this floating around. People might call it clear box testing, glass box testing, or structural testing. But don't let that fool you. They all mean the exact same thing. The goal is total transparency, being able to see right through the box to understand how all the parts are connected.
The Lego car analogy makes this crystal clear. Black box testing is just giving the car a push and seeing if it rolls across the floor. White box testing, that's taking it apart, brick by brick, to make sure the axle is connected to the wheels just right, and every single piece is exactly where it should be. It's all about that internal structure.
So, if you're the mechanic with the hood open, how do you know what to check? You can't just poke around randomly. There's actually a pretty structured approach, with 4 key levels of inspection, and each one gets a little more intense than the last. So let's start with level 1.
First up, we have statement coverage. The goal here is simple, but it's absolutely crucial. You just want to make sure that every single line of code that can be executed gets run at least one time during your tests. It's like a baseline check to make sure no part of your code is being completely ignored. Let's make this real with a quick gaming example. To get full statement coverage here, your tests would have to trigger the start game function, then the show intro function, then play music, and finally enter level 1. You're literally just confirming that the program can successfully run every single step in this sequence. But just running every line isn't quite enough, right? Because code is full of choices. If this happens, do that. And that brings us to our second, deeper level. Decision coverage. Sometimes it's called branch coverage. Here, the goal is to test every possible outcome of those choices to make sure you've explored every single fork in the road.
Let's go back to our game. Imagine there's a piece of logic that says, if score greater than 100. Well, it's not enough to just test what happens when the player wins. For good decision coverage, you have to test both paths. One test case where the score is, say, 150, and another where the score is only 50. You've got to verify both the win logic and the try again logic.
Okay, now we're going to get even more detailed. What happens when a decision isn't just one simple question, but a few questions combined? That is where condition coverage comes in. This is all about breaking down a complex decision into its smaller parts and testing each one of those individual pieces.
For example, maybe to open a special door in your game, you need to have more than 10 coins and have more than 0 health. Well, just testing the one case where both are true isn't enough. Condition coverage forces you to check every single possibility. What if you have enough coins, but no health? What if you have full health, but not enough coins? This is how you find those sneaky little bugs.
And finally, we have arrived at the heavyweight champion of them all, path coverage. This is, by far, the most thorough and complex technique. The goal here is to identify and test every single possible route that the program could take from start to finish.
Think of your application's code like a maze. There might be a bunch of different ways to get from the entrance to the exit. Path coverage is basically like mapping out that entire maze and then methodically walking down every possible path to make sure they all work correctly, with no dead ends or weird surprises. So we've looked at these 4 different levels of inspection, from a simple line check all the way to navigating a complex maze. But who is actually doing this navigating, and what kind of tools are they using to map it all out?
Well, this isn't a job for just anyone. This kind of deep dive testing is usually done by the developers who actually wrote the code, or by highly skilled automation testers who can read code fluently. And here's the key: it happens early. It's a huge part of unit testing where you're just checking the tiny individual Lego bricks, and integration testing where you're making sure all those bricks snap together correctly.
And thank goodness they are not doing all of this by hand. There's an entire ecosystem of automated tools to help. You've got testing frameworks like JUnit, NUnit, and PyTest. Those are the workhorses for different languages. And then you have these incredibly powerful analysis tools like SonarQube or Clover, which basically act like a report card, telling you exactly how much of your code is covered by tests.
All right, we've gone pretty deep into the techniques, the people, the tools, but let's zoom back out for a second. Why on earth do we go to all this trouble? Why does opening up that white box and digging around in the code matter so much? This table really brings it all home. So who's doing it? The developers and technical testers. What are they testing? The code, the logic, all those conditions and paths. They do it early on during unit and integration testing. But the most important question here is why? And the answer is to catch bugs as early as possible and to make sure the code isn't just working, it's working perfectly.
And that quote really nails it. I mean, think about it. Finding a problem with the foundation of a house when you're just laying the concrete is way, way easier and cheaper to fix than trying to fix it after the whole house has been built. It's all about being proactive with quality.
So the next time your phone pops up with an app update for bug fixes and performance improvements, I hope you'll have a brand new appreciation for what went into it. Maybe you'll think about that invisible web of code paths, all the decisions and conditions that were meticulously tested, just to make sure that when you press that button, it works flawlessly every single time.